So let me recall you the epsilon delta definition for single variable first. Then we do for the two variable case. Okay, Mayan?
Okay, sure.
Right. So this chapter is basically limit by epsilon delta definition. Let's divide this chapter into two parts. The first part we explain for the single variable. So in the section A, we discuss for single variable. So we have one input. I mean, we have one independent variable. So let y equal to fx is a given function. And suppose f is defined at near a point A. Okay, Mayan?
Yeah, fine.
All right. We have a function y equal to fx, and the function f is defined near a point A. So we are interested about the value of fx when x taking value near a. So let me write here. So that I am writing here. So we write limit x tends to a fx equal to L. This means so the function fx tends to L as x tends to a along real line. Okay, Mayan?
Okay.
All right. So what will be the definition? We say this limit is L if and only if for each epsilon greater than 0 there exists a delta greater than 0. That delta we will find. We select epsilon and we find a delta. There exists delta greater than 0 such that, of course, the delta will depend on epsilon. So here it is. And this is depend on epsilon. There is delta greater than 0 such that fx minus L absolute value less than epsilon when 0 less than x minus a absolute value less than delta. This is the epsilon delta definition for limit. Okay, Mayan? Right? Right. So for every epsilon, we have to find a delta. This absolute value less than epsilon when this less than delta. So this is the definition. Now I will tell you how to solve this kind of question. And here we do for two kind of function. One we do for linear function and one we do for quadratic function. Okay, Mayan? Because in your test, you will get one from linear function and one you get from the quadratic function. So let me give you an example. So that here the example, and then I will tell you. Just follow how I am doing this, then you can solve. Okay, man? So that so that limit x tends to 2, 3x plus 5, this function limit equal to 11. Man, can you see question?
No, that's fine.
All right. So we prove this by epsilon delta definition. Okay. So here is the solution. So how we start this? So first we consider, always you will consider the function fx. Fx equal to, here we have 3x plus 5. Now in the next step, what you do? You will calculate fx minus 11. So now immediately you have to calculate that. Absolute value of fx minus 11. So that 11 we are getting from here. So what is this? This is basically absolute value of 3x plus 5 minus 11. So this absolute value. So what is this? This is basically 3x minus 6. Mayan, is it okay?
Yeah, it's fine.
Always you have to start like this. Yes. Now what you have to do? This side you have to bring a factor x minus 2 because we are interested x tend to 2. So we need a factor. So we need x minus 2 absolute value in right hand side. So that we are going to do, and we can easily do it. How? So 3 factor out, then we get here x minus 2 absolute value. So then what is this? This is 3 into x minus 2 absolute value. Mayan, so far it's clear.
Yeah, fine.
Very good. Now see, suppose you have here x minus 3. I mean, if you have x tend to 3, then you need x minus 3 absolute value. That factor, right? All right. So let me write it here. What we have get. So we get it here that fx minus 11 absolute value is what? This is nothing but 3 into x minus 2 absolute value. Now let epsilon greater than 0. So we select the epsilon. Now see. Now, fx minus L, this, I mean 11 less than epsilon if this expression less than epsilon, right Mayan? Is it okay? Mayan?
Yeah.
All right. So now, so what we get? We get fx minus 11 absolute value less than epsilon if x minus 2 absolute value less than epsilon divided by 3. So let delta greater than 0. Sorry, let delta equal to epsilon by 3. So then what we are getting? Fx minus 11 absolute value less than epsilon if 0 less than x minus 2 less than delta, where delta you write delta equal to epsilon by 3. Mine clear?
Yeah, fine.
All right. So what we are getting? So we are getting limit x tend to 2, fx equal to 11. That's all. So this we did for linear function because our function was linear, right? Look at this. We have a linear function 3x plus 5 like that. Clear? We first consider fx is our function that we have given. Then we calculate absolute value of fx minus 11. That we calculate this, and then 3 factor out this, and then 3 like that. And this way. We get this. Actually, this difference is nothing but 3 into x minus 2 absolute value. Select epsilon. Now this expression less than epsilon if this less than epsilon. So this less than epsilon if this less than epsilon by 3. So delta equal to epsilon by 3 and this way. One more example. Let me tell you here. Let's say this is example 2. So that limit x tends to 0, 3x plus 5 equals to 5. Okay, Maya?
Okay.
Okay, this one we prove. Yeah. So here the solution. Yes. How do? So we consider fx equal to 3x plus 5. Man, clear?
Yeah.
Okay. Now what we do? As I told you, first you have to calculate fx minus 5 absolute value. So what is this? Absolute value of 3x plus 5 minus 5 absolute value. So then what we get? We get here 3x absolute value. Now see, we have here x tends to 0. So we need factor. We need, I'm just writing here. You will not write in the exam, this part. Okay. This you will not write. Okay, Mayan, this part. Just for convenience, I am telling you, for your understanding. Okay. So what should we get? We get here 3 into absolute value of x. And this is nothing but 3 into x minus 0 absolute value. Alright, so we get fx minus 5 absolute value equal to 3 into x minus 0 absolute value. Mayan, any question so far?
No, that's fine.
Alright, so let epsilon greater than 0. So now fx minus 5 absolute value less than epsilon if 3x minus 0, this is less than epsilon. So what should we get? We get here fx minus 5 absolute value less than epsilon if x minus 0 absolute value less than epsilon by 3. So let delta equal to epsilon by 3. So what should we get? We get fx minus 5 absolute value less than epsilon if 0 less than x minus 0 absolute value less than delta. Mayan, it is clear?
Wait, what?
Okay, fine so far.
Yeah, that's fine.
Should I give an example? You try.
Can you show how to do epsilon delta but with a quadratic?
Yeah. Oh, yeah, I will do. So linear is clear? Linear?
Linear is fine. For
All right.
this linear though, don't you have to go like backwards?
Backward, yes, okay. We did actually. Yeah. You can, if you do this way, also is correct. You know, it's
Because
proper way
that's what
I
my
have.
teacher did. You saw in the notes, what I sent. He
Yeah, he
goes
did. He did
backwards and then
backward,
he
backward.
goes,
He did backward.
yeah,
Yes,
he
I
gets
saw.
the same original statement at the start.
Same thing, man. Man, same thing. Don't worry. Okay.
Okay. So I can
Same
do his way or my way, it doesn't matter.
this way exactly. Because first you, this is first important part. This. Firstly, you have to develop
Okay.
this equation. Fx minus limit mod is 3 into x minus a like that. Then choose
Okay.
epsilon. Yeah, this less than epsilon if this expression less than epsilon. So this if this these are done. Okay,
Okay, sure.
very much pretty clear language.
Can you
Okay,
show quadratic now?
yeah, I will do now. Yes, now quadratic. Quadratic little bit, you know, you have to use your brain, but it's okay, fine. So now the quadratic function, if you have, I will tell you three example. I mean, two example basically. Then you understand actually what we are doing. So one more step you have to do here. So that so this is let's say example one. So that limit x tend to 2, x square equal to 4. Mayan, clear?
Yeah, fine.
Okay, this is quadratic because x square you have. So let's solve it. Solution. We have x tend to 2, right? So how to do? So first write function. Let fx equal to x square. This is our fx. Now, what should we do? Fx minus 4 absolute value. This is what? This is basically x square minus 4 absolute value. But see, we need x minus 2, right, Mayan? Because x tend to 2 we have, right? Mayan.
Yeah.
All right. So we need a x minus 2 here in the right hand side. So we can do it. How? So this side you can factor, right? X minus 2, x plus 2 into x minus 2. Is it okay?
Yeah, fine.
Very good. Now we take the absolute value of separate function x plus 2 and x minus 2. Fine. Is this clear? Do you agree from this step to this step?
Yeah, that's fine.
Right. The problem part is this. We have to somehow remove this, or you can say we will replace this by a constant near point 2 because we are interested at the point 2. Okay, man? So how we do this? See, so far what we get? We get this equal to this. Now see, so so we get, let me write here. So our point is here, 2. So we consider a neighborhood around 2. So the natural neighborhood will be 1, 2, 3. Okay, Mayan, clear? See, Mayan, we
Okay,
are
fine. Yeah.
yes, we are interested at the point 2. So we will consider a neighborhood around 2. So it is naturally we can take 1, 2, 3, this open interval. Yes. So let me write it here. So for 1 less than x less than 3, what should we get? We get both side we add by 2 because we have x plus 2. So that is 3 less than x plus 2 less than 5. So x plus 2 is in between 3 and 5. So this means what should we get? 1 second, man. 1 second. Hello. প্রথমে তো বের করতে বলেছে মনে হয় না, a into adjoint হবে। অ্যাডজয়েন্ট অফ এটা তো তুই বের করবি, নরমালি একটা ম্যাট্রিক্সের প্রতিটা এন্ট্রির কোফ্যাক্টর বের করে পজিশনটাই বসিয়ে দিবি। ও না, এখানে এই যে ওইটা করলে হবে
Wait,
না।
why is it in
ওইটা
between 1 and 3
এইভাবে কর।
again?
রাখ, হ্যাঁ। ইয়েস, ইয়েস, সরি।
Why is x in between 1 and 3 again?
Yeah, because we are interested about 2, right? Because we are interested at the point 2, right?
Mm-hmm.
So we consider a neighborhood around 2. So naturally 1, 2, 3 we take. Okay. So
Oh, like that. Okay.
yeah, if you have point 5, then what will be the interval? 4 to 6. Got it?
Sure.
Like that. It depends on. At which point you are taking the limit. All right. So x plus 2 is between 3 and 5. So what should we get? X plus 2 absolute value must less than 5. Right?
Okay.
Yeah. So what should we get? So we get this absolute value less than 5. So we get, I have to write in the next line. So that is called 1. This is called 2. By 1, 2, we get fx minus 4 absolute value is less than 5 into x minus 2 absolute value. Mayan, is it clear? If 1 less than x less than 3. Is this clear, Mayan?
Yeah, fine.
Why? Because this is less than 5. This expression equal to this into this, and this is less than 5. So, this expression is less than 5 into x minus 2 absolute value. So therefore, this is less than 5 into x minus 2 absolute value. Right? Okay, Mayan, clear?
Yeah, fine.
Right. Now here we select epsilon greater than 0. Now rest work is the same thing. Let epsilon greater than 0. So fx minus 4 absolute value less than epsilon if 5 into x minus 2 absolute value less than delta. Sorry, less than epsilon. If this part less than epsilon, right? This part, then automatically this part will be less than epsilon. So what should we get? Fx minus 4 absolute value less than epsilon if x minus 2 less than epsilon by 5. So
Wait,
let
how'd you get the 5 times x minus 2?
this one. Look at this. We have here what we have. Fx minus 4. Look at what should we get here? Fx minus 4 absolute value of this, right?
Yeah.
Now see, this term is less than 5 because of this on this interval, right? We have seen this,
Yeah,
right?
that's fine.
So therefore, this term less than 5 mean total product. This into this less than 5 into this. So therefore, this less than 5 into x minus 2 absolute value, right?
Wait. Can you say that again?
All right. So let me tell you here what we had. We had fx minus 4 absolute value. It is x plus 2 absolute value into x minus 2 absolute value, right? By
Yeah.
1? Yes. Now what we know? We know x plus 2 absolute value less than 5 if 1 less than x less than 3. Because of this, right, man?
Yeah.
So this means this term less than 5 if x is in between 1 and 3. So the total product will be less than 5 into x minus 2, right?
So x plus 2 times x minus 2 should be less than 5?
No, 5 into. If you product both sides, see. So if you have this on this interval. Now what we are doing? We are both side multiplying by x minus 2 absolute value. So what should we get? 5 into x minus 2 absolute value. Is it okay?
Yeah.
So this means what? This is nothing but this. So what should we get? We get fx minus 4 absolute value less than 5 into x minus 2 absolute value. So that I immediately wrote here.
Wait, let me get this clear. So x plus 2 absolute value is less than 5
Hmm.
from um going in between 1 and 3 and then
Yes.
doing the operation to get x plus 2 is less than 5. Then um how do you say that x plus 2 times x minus 2 is less than 5 times x minus 2?
No, no. We know x plus 2 less than 5, right?
Mm-hmm.
So see. If a less than, let's say, what we have? We have x plus 2 less than 5. We have this, right?
Yeah.
If we both side multiple by a positive number, then inequality will not change, right? Is it okay?
Oh, because you're multiplying both sides. Yeah, sure.
Yeah. And this is nothing but fx minus 4, absolute value. So this is less than I don't.
Oh, okay, I get it.
Yeah, that 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 is the trick here.
Okay.
It's an elementary calculation, right?
Mm-hmm.
Okay. So let delta equal to epsilon by 5. So we get fx minus 4 less than epsilon if 0 less than x minus 2 less than delta. Fine.
Yeah.
Okay. Let's do one more example.
Okay.
Okay. Example 2. So that limit extend to 1, 5x square plus 7x plus 3 equal to 15. Okay, Maya? We'll see that. For the solution. So fx is what? Now now we calculate the difference. That is what? Right? So what is this? Is it okay, Mayan? Clear? Mayan, is clear?
Yeah, this is fine.
Okay. All right.
Wait, one question.
Hmm. No, they are 15, 15. Sorry, I did mistake. They are 15.
Yeah, yeah, why do you, I was about to say 1 minus 5.
Mm-hmm. Now okay, right? Now okay.
Um, what do you do f of x minus 5?
Oh,
Okay.
hmm,
Yeah, that's fine.
that's okay. Now this one, so we middle term it, right? So we factor it into two linear factors. So how we do that? So
Uh,
5 into 12, 60. Yes.
it's like 5x plus 12 and then x minus 1.
Yes. No. Let me. Yeah. That is fine. So yeah. So that is okay. Okay. So tell me what you. So 5x plus 12. This, is it okay, Mayan?
Yeah, it's fine.
Right. So what we get? We get here 5x plus 12 absolute value into x minus 1 absolute value. We have to eliminate this term. Right, Mayan?
Right.
Okay. So we get, let me write what we have. We get fx minus 15 absolute value is nothing but absolute value of 5x plus 12 into absolute value of x minus 1. That we have. Now, see, at which point we are interested? At point 1. So we consider a neighborhood around 1. So let me do it here. So here 1. So natural, you can consider 0 to 2, this neighborhood. One is clear. So now,
Yeah.
now for 0 less than x less than 2. So what should we say? We need 5x plus 12. So both side we multiply by 5. So we'll get 0 less than 5x and this is less than 10. So 5x plus 12. So 0 plus 12 less than 5x plus 12 less than 10 plus 12. So what should we get? 12 less than 5x plus 12 less than 22. Mine, is it clear? Fine, mine.
Yeah.
Okay. So absolute value of this 5x plus 12, that absolute value is less than 22. So what we get? So this is 1, say 1, and this is 2. By 1, 2, we get fx minus 15 is less than 22 into x minus 1 absolute value. Clear, man?
Yeah.
So choose. So let epsilon greater than 0. Now fx minus 15 less than epsilon if 22 x minus 1 less than epsilon. So what should we get here? So get here, let delta your choose epsilon by 22. So we get fx minus 15 less than epsilon if 0 less than x minus 1 absolute value less than delta. Done. Man, clear.
Yeah.
Okay. You can see this kind of question. Always you consider your function fx, then you calculate the difference of fx and limit, and then in the right hand side you need to bring a factor x minus the point basically. That we have done here. And then we did it. And the unnecessary term that we had here, that we actually replaced by a constant near the point 1 by this way. And we get this basically. And then choose epsilon and that delta we select from here epsilon by 22. So then get it. Same, if you have linear function, then this extra step not need to do for the linear function. You get immediately the factor in the right hand side. But if you have quadratic, then this extra step you have to do. Okay, Mayan, clear?
Yeah.
Okay. So I'll send a new link and then we do the function for two variables. Or maybe squeeze lemma first we solve. Then we do the function of two variables. Let me send a new link. Okay. Mayan, should I send a new link?
Yeah, sure.
Okay. You can see this in your YouTube. Today I am going to upload all of my video that you have needed it. This lecture you can see after class also. Okay.
Okay. Can you send the link
Yeah,
to it?
I'll send. Yes, definitely.
Okay.
Yes. Okay. Bye.
Bye.